So, our lesson is about simplified design-based shear. So, there are three methods in finding the design-based shear. We have the simplified design-based shear, we have the static, and we have the dynamic design-based shear. So, let's start with the simplified design-based shear. So, the problem in here is that determine the base shear and the design lateral force for a two-story reinforced concrete special moment resisting frame office building using the simplified design base shear given the following information. So, in the information that is given, the frame of the building is, the height of the building is 8 meters and we have 12 meters width with story weight 900 kilonewton above and 600 kilonewton at the second floor. Okay, so the zone of the building, the seismic zone is seismic zone 4. So the seismic zone factor would be 0.4. The seismic source type is determined to be type C and the soil profile type is unknown. So when the soil profile type is unknown, we'll have to assume type SD, right? And the R, since it is an SMRF, the R of the building is 8.5. So this is in the NSCP. So on how we determine for R, and the total weight of the building of the frame is 1,500 kilonewtons. So the first method in finding the design base shear is that we have to determine what procedure shall we use. So let us check if the simplified method is applicable in this frame. So that's the first thing that we're going to do. So check. So first is to check applicability. Check the applicability of the method. So what are the requirements in using simplified design base shear? So in the NSCP, it is said that the simplified static lateral force procedure may be used for the following structures of occupancy category 4 or 5. So the occupancy category 4 or 5. So what are these? These are buildings of any occupancy not more than 3 stories in height, excluding basement that use light frame construction, or other buildings not more than 2 stories in height. So in this one, the building is not more than 2 stories in height because it is exactly 2-story reinforced concrete SMRF. So our building is covered by the simplified method. So in our NSCP, so is it in the part where it is buildings of any occupancy not more than 3 stories in height that use light frame construction? This does not use light frame construction, but it is under the category of other buildings not more than 2 stories. So we can use, so since it is not more than 2 stories in height, since it's not more than 2 stories in height, excluding basement, it doesn't have a basement, we can use the simplified method. Okay, so now the next step is to determine the base shear. So since the soil profile type is not known, we shall use soil profile type SD. So soil profile type would be SD. And the NA is what? The seismic source type is C. And our NA, since the seismic source type is C and the soil profile type is SD, NA is 1.0 based on the table on the and SCP. And since it is in seismic zone 4, so we have to apply CA. So CA is 0.44 of NA. So soil profile type SD and NA equal to 1. So CA is what? 0.44 times 1. So our CA is equal to 0.44. So now to compute the design base shear, it is very easy because it is provided in the NSCP that the formula would be V is equal to 3.0 CA over RW. So V is 3.0, CA is 0.44 over 8.5 times the total weight of the building, that is 1,500. So RV is equal to 233 kilonewton. So that is the base shear. So the next step upon determining the base shear is for us to distribute the force at each level. So we'll designate this as level 1 and this one as level 2. So we're going to check if what is the distributed force here in level 2 and the distributed force in level 1. Since we got our design base shear, that is 233 kilonewton. So I'm going to copy that one. Wait. Okay, now we have our design base shear, that is 233 kilonewton, and we're going to distribute it. We have our F1 and F2. So the third step would be to determine lateral force at each level. So we're going to determine the lateral force at each level. So for us to determine this one, it is the proper way to distribute it is by ratio and proportion to its weight. So if we're going to get F1, it is 3.0 CAR of its own weight. So this is how we distribute it, that is Fx. So F1 would be 3.0 times 0.44 over 8.5 times the weight of F1 is 600. And the weight of F2 is 900. So our F1 would be 93 kilonewton and our F2 would be 140 kilonewton. Okay? So that's how we distribute the lateral force at each level. So at this level, so I think the the figure got it wrong ata, because 600 would be at the top sana and 900 would be at the F1. Mali pala yung pagkaganyan ko kasi dito. This should be F2 and this should be F1. Pero feeling ko nagkamali itong ganyan. Kasi dapat lighter yung nasa taas kasi roof lang naman yun. Tapos 900 sana yung andito sa first level. Kaso, ganyan na siya eh. Kaya, i-follow na lang natin. So, ganyan yung distribution of forces. Actually, naka-ratio proportion lang naman siya dun sa kanyang weight. Okay, so, that is how we determine the lateral force at each level. So, when will we use simplified design base shear? When the building is not more than 2 stories in height. Okay, so this is how we use simplified design base shear. Okay, so that's it for this topic.